Alright, I think I'm going to entitle this video series The Messy Tech. Anyway, this is a DBX 266XL. When I got this, the bypass? No, the over easy button wasn't sticking in. I've already repaired it, but what I'm going to do with this video is I'm going to go in and repeat the repair with let's say the other over easy button on the other side, just to show you how the button goes in and out and how to disassemble the thing. Okay, thanks. Be back in a second. Okay, I'm going to start with the disassembly. Some screws over on the side. I want to make sure I got this in the video this time. And these are just Phillips screws. Okay, and there's one Allen screw in the center. You're going to have to take out in order to get the top off. And according to my kit here, it is a 7/64. Just want to make sure that we're still in frame here. Yeah, there's two more on the side have to come off. Alright, and there you have it. And we're going to have to do some more disassembly. As you can see down in here are the switches. We'll talk about that transformer later. That's not part of this, but someone had asked what's the voltage on that. I remember it was a 25 volt center tap, if I'm not mistaken. I'm going to include a picture of that later with a voltage reading on it. Pull the plug on that board and disconnect it. Set to the side. Just don't want to make sure I'm in frame. Okay, you got these standoffs which have to be removed. I believe. Bear with me 1 second. Yeah, see those standoffs in there. Okay, they can be removed with a 1/4-inch nut driver, so you have to remove 1, 2, 3 standoffs and then 1, 2, 3 screws. Oh, I'm sorry, I lied. There's actually 1, 2, 3, and there's a 4th screw back by the power supply. So we'll pull the power supply connector off and get to the screws. I'm not using any special tools to remove these switches. I'll pull this connector off. I'm not using any special tool to remove one of these switches. But it is a pretty thick circuit board, and just a regular solder sucker like this one is not going to do the job, and desoldering braid is not going to do the job either. The technique I'm going to use here to remove that switch is something that we used to call solder blobbing. It's where you just you cover the top of that with so much solder and you keep it hot so that all of the pins are heated simultaneously, and then the switch is going to fall out. So let me take a second to get set up for that and I'll come right back. Okay, there's two types of switches in here. There are these 12 pin, that's 2, 4, 6, 8, 10, 12 pin switches, and these 6 pin switches on the end, 2, 4, 6. Okay, you just need to know which one you're ordering when you do. Okay. Alright, I'm going to go ahead now and pull out this over easy switch. I'm using this arrow to try to keep me in frame here. Going to have to pull on that switch just a little, but you don't want to do it so much that you're going to rip any traces. And you kind of also want to keep it level, because if you don't keep it level, what's going to happen is the solder is going to run from one end to the other. Okay, now most of the connectors have already fallen through, and this is a spot where I'm probably going to have to, I wish I would get better focus. Anyway, most of it has already fallen through. I didn't get a clean drop that time. So I'm going to put some more solder on the top and heat it up and push it through again. Actually, I don't need this part here anymore. This is professional filmmaking at its finest. Are we still in frame? Yep. Okay. Not the cleanest of tricks all the time. Right now I'm just running this across the legs, get this to pop up. First one I did was, of course, a lot cleaner, and that's not the one that I videoed. Just about there. And not to keep the heat over any one particular connection for too long. comes out. Now that was not my best solder blobbing ever. I mean, it's a whatever. I'm going to make up 1,000 excuses why I botched that. But nonetheless, she came out nice. This is the front end of the switch, which operates the LED passes through to let you know that the compressor is in. Let's put that aside. If I had disassembled this whole front end, I would have been able to remove this piece quicker, and it might have made the switch fall better. But anyway, now that we're to this point, I'm going to take a break on the video, and I need to come back and use solder wick to clean out all the holes. Alright, one thing about doing the solder blob technique is every once in a while you might get a stray piece of solder that runs over the board and short something out. So you really want to inspect the area real good and make sure that there's no stray pieces of solder. You can see this one came out very clean. All right, now I'm going to start wicking it out. And trying to also get it in the shot, and that's where I'm going to be working. I may have to hit this board from both sides to get this to come out. Well, one hole cleaned up well. If you've never done solder wick before, there's some great tutorials out there on soldering by Pace, and I'm definitely going to link to them. I think they were made in the 70s or the 80s, but I mean they all still apply. And who better than to get your soldering information than the Soldering Iron Equipment Manufacturing Company. I've seen those guys on those videos do some unbelievable solder work. They're just got a lot of experience and a lot of know-how. Far superior to anything I've ever done. Again, like most of my videos, I realize they might be long and boring, but sometimes you do want to see the whole process, and rather than assume, I'm going to let you see all the little things that might happen. I'm certainly not trying to look like the world's best soldering guy in the world. I put a little bit of solder on top of the wick. It lets everything start flowing real well. I twist it back and forth just a touch. That seems to suck a hole better. I got most of these. I'm only missing one. And usually that's when it's like attached to a ground plane or a power supply, when it it's a little harder to get the thing to flow. So I'm going to give it a little more solder. Hit it. And I'm still not getting through, so here I'm going to have to, I'll flip the board. And give it a try from the back. There's no, doesn't seem to be any power grid on that, so I'm not sure why I didn't get a good flow. Bound to get one little toughie in there. Ah, there she goes. Opened up. Alright, that looks like just a little bit of solder is still left in this front hole. Okay, I checked these. Kind of hard to see here, but I'll hold them up to the light, and if you can clearly see daylight coming through the holes, you know you've got it all. Alright, here's my old switch, which this is not really destructive, but for the most part kind of a destructive procedure. So when you remove the switch, you're going to really, you might get a little bit of melt going on, and the legs are going to be all clogged up with solder, so it's kind of a throwaway thing at this point in time. Well, anyway, here's the old one. Like I said, it wasn't actually defective. I've already replaced the defective switch. What was happening was it was not latching. It was just going in and coming out. And here's my new replacement switch. Nice and clean and ready to go in. Alright, so when you put that back in, you're going to mount the LED light segment. Just push that over into the hole, line up your legs, and drop it in place. Now it's ready to be soldered back on. Now that was really some clean holes I made there, so I'm hoping this doesn't fall through. What I would do at this point, I want to make sure I'm in frame. I just want to tack two corners. I usually go for two opposite corners. And then your finger on the switch on one side, put a little bit of pressure on it and heat those joints back up again. That way it'll push the switch flush against the board. And then before you continue and start soldering, you definitely want to put a visual inspection to make sure you're tacked into the right place. And I can see by looking at this switch that it's down. And you can already see that the operation has been restored, should this have been a bad switch. You can also use this repair if the switches are noisy. I mean, if you're a real gung-ho guy, you can pull your switch out, disassemble it, and clean it, which I have actually done that before. But I am going to tell you, I won't do that again, because sometimes it works and sometimes it doesn't, and you'll be in that switch. You might put it in 3-4 times. So it's kind of, you know, considering the cost of a switch, buy a switch. Alright, now I'm just, am I in frame? Yeah. Just going to solder the rest of these on. Notice I put a little rocking pressure as I'm soldering. What that does is it moves the lead back and forth and allows the solder to go through the hole. Very nice. Okay, and there we go. That's all ready to that's ready to put back in the circuit and test. So I'm going to stop the video here and get back to the assembly. Alright, I don't know if it's really necessary for me to film the reassembly, but I'm going to do it anyway. But I do want to point a couple things out. Whenever you have a component on the board like this that's heavy, mounted on a heat sink, say a transformer, a power transistor, sometimes these potentiometers, anything that's board mounted, it's always a good idea while you're inside and you have it open and you're able to, is just reflow the solder. because these are the kind of points that will fail. It's very common that anything attached to the board is going to fail. It's true for USB connectors, DC power jacks, headphone jacks. Those are just one of the most common kind of repairs that take place. So you want to go around all those and hit them. And you can definitely tell the ones that you did, because they're going to be the ones that are really nice and shiny. And another thing, which is something of debate, and I'm a little curious, I'd like some feedback on this. I have used either WD-40 or CRC nearly all my life to take the crackle out of potentiometers. And I have read in a few places that a lot of guys don't like doing that. I don't know. I've never had any failure after hitting a pot with WD-40. Not that this unit particularly needs it, but as long as I'm here, I'm going to show you one thing that can be done. Okay, I take this can and I'll bend it, and you'll see on the back of any pot, there's usually a small opening, and you just want the smallest. You just want the smallest amount to get in there. You're not trying to douse it. Alright, and bear with me, I'm just going to get a paper towel. You want the loose stuff, because this does have a little bit of odor and it might irk some people, but nonetheless you're going to get a clean pot out of it. And then once you get the WD-40 in, you'll work it back and forth, and you're 90% guaranteed to fix any related problem like that. Now, there are some pots that simply need being replaced. You know, if you want to go ahead and do that, you know, they're a couple bucks a piece, and it's a lot of labor to take it off for something you probably don't need to do. So that's my thing on WD-40. Now I'm going to break the video again and continue assembling. Sometimes the screw just doesn't want to go. I don't want to force it. That goes better. Frame. I think I looked at one of my other videos and there was a 3 or 4 minute segment in it, and all you're looking at is the back of my hand doing what he knows. I don't know if you can hear it on the video, but there's some sort of fireworks going on outside. Okay, and again, like when you're in on any other circuit, just look for poofy caps. You're not going to see that so much on a unit with an analog power supply, but you'll see it with units with switching power supplies. go. Everything's nice and in place. I'm going to break the video again. So I'm going to come back and take the readings on the power supply and the test points. Some other people somewhere had some questions about that. I just wanted to verify. So I'll be back in a second. Alright, I'm back. I just wanted to take some quick power supply readings here. On the board it's marked that there's ground, negative 15 and positive 15. Let me put that there. You're still seeing it? Yeah, DC, right? There's your positive 15, negative 15. All right, now I want to look at the transformer itself. So I got that set on 200. There's 3 wires coming off of it, blue, white, blue. Usually that means it's a center tap. So if you go between the 2 blue lugs, why am I not seeing anything here? Okay, between the 2 blue lugs under load it says 46, and so between any blue and any white should be half of that. And it is. It's 24. Alright, so it's a 48 volt, 50 volt center tap transformer. Anything in that range should work. The part number on it is 0245 26-0245A, and I'm imagining that's just a whichever you come up with, 48, 50 volts. I'm not exactly sure what that number says, what that number implies. It might mean it's a 26 volt center tap, and then under load it drops down a little bit. So anything in that range should work, because you're sending that analog regulated through these linear 15 volt regulators. So anything in that range should be fine for this circuit. Okay, that's it. I'm going to hook it up, test it, and just go from there.